Greetings and welcome. In this session we will see how to measure a pressure. Subsequently you will be able to explain what is pressure, types of pressure and pressure measuring devices. Let us see what is a pressure. From this image we see this is the application of force on the unit area. So the force applied perpendicular to the surface of an object per unit area over which that force is distributed is called as pressure. Mathematically it is given as small p is equal to force F upon area A, and its unit is Newton per meter square, which is also called as Pascal. There are some other units of pressure which are used in the calculations. For the atmospheric pressure, the unit is used, that is 1 atm, that is equal to 1.01325 into 10 raised to 5 Pascal. Here it is given in kilopascal. In terms of mercury height column, it is given as 760 millimeter of mercury column, which is called as 1 torr or torr. In a bar, atmospheric pressure is given as 1.01325 bar. In a millibar, this is a value given, and this is given in a pound per square inch, means 1 atmospheric pressure is equal to 14.7 psi. Types of pressure. Prominent types are atmospheric pressure, absolute pressure and gauge pressure. Atmospheric pressure: the atmospheric air exerts a normal pressure upon all surfaces with which it is in contact. So atmospheric pressure is acting on all the surfaces or all the objects which are present on the earth. It is known as atmospheric pressure. It is also called as barometric pressure. Here from this diagram we see the atmospheric pressure at sea level, that is called as standard atmospheric pressure. It is given equal to 1.01325 bar. So here this is a horizontal scale in which pressure is mentioned in a millibar. 1 bar is equal to 1000 millibar. So this is the maximum pressure which is at the 0 kilometer altitude of sea level. This is the curve which gives the relation between the variation of pressure with respect to height. So here we find about 35 kilometer altitude. At this level the standard atmospheric pressure is 0, means at this level or above this level there is no molecule movement of the air present. Here we find this is the level at which aeroplane is flying. So it is about 12 kilometer. At that level the pressure intensity available atmospheric air is less than 200 millibar. On the earth the highest location is Mount Everest. Its altitude is 8.8 kilometer. So at this location the pressure available atmospheric air is about 100 millibar. So in this way, on this curve we can have the different values of the pressure with respect to altitude in a kilometer. So here these are the atmospheric pressure values given in different units. Gauge pressure: the pressure given by the measuring instrument in which the atmospheric pressure is taken as datum, that is called as gauge pressure. So these are the two gauges, one is a positive gauge and another is a vacuum gauge or negative gauge. So the pressure given by these two gauges, one is a positive gauge pressure and another is negative gauge pressure. Absolute pressure is a total pressure. So this is the pressure measured above the absolute zero of a pressure, which is termed as an absolute pressure. So there are two relations. For positive pressures, absolute pressure is calculated by summing up atmospheric and gauge pressure values, and for negative pressures applications, absolute pressure is calculated by taking the difference of atmospheric and gauge pressure of the instrument. We can learn a relationship between the pressure by using this diagram. Here this is the line which is showing absolute zero pressure. This is the line which is showing atmospheric pressure. So in case of positive pressure applications, the gauge pressure read by the gauge, that is called as gauge pressure, that is above atmospheric. So in that case, absolute pressure will be sum of local atmospheric pressure and gauge pressure. In case of applications where the vacuum is present, means pressure below atmospheric value is present, in that case this is the vacuum pressure shown by this line which is below this atmospheric pressure line. So this is the pressure, that is negative absolute pressure. It can be obtained by subtracting this vacuum pressure gauge value from this local atmospheric pressure. So these are the two cases by which absolute pressure can be obtained. Pressure measuring devices. So basically there are two types, manometers and mechanical gauges. Manometers are the devices in which pressure at a point in a fluid is measured by balancing the column of a fluid. And mechanical gauges are the instruments in which pressure is measured by balancing the fluid column by using elastic element, that is a spring or dead weight. Piezometer is an instrument which is used to measure the liquid pressure. Generally it is used to measure low pressure in a system by measuring the height to which a column of liquid rises against gravity. Means this tube which is connected to the system, that is called as piezometer tube, its another end is open to the atmosphere. So this is the height of liquid which is rising in this tube. Now in this case the liquid in the tube is the same which is present in the system. In this case gauge pressure can be calculated by using formula rho into G into H, where rho is the density of fluid which is present here, G 9.81, and H is the height of the fluid which is rising in this tube. Differential U-tube manometer, which is used to measure the difference of pressure between the 2 points of the pipes. For example, here this is a location A and location B in a pipe. So these two ends are connected of this U-tube at the pipe A location and pipe B location. In this case, the manometric fluid which is used here is different than the system fluid, and again it is heavier or denser than the system fluid. Most of the time this fluid is used as a mercury. So in this case, depending upon the intensity of pressure, in this case as the pressure on A side is more, that's why the mercury fluid is pushed by the fluid in system A and it is rising in the right limb by height H. So here difference in a pressure is given by this equation. PA means intensity of pressure at location A minus PB, means intensity of pressure at location B, is equal to rho is the density of manometric fluid into 9.81 into level difference, that is H. Pressure gauges, these are mechanical gauges. These are the instruments designed to measure pressure of a system in which the atmospheric pressure is taken as a datum, means atmospheric pressure on the scale is marked as 0. It does not mean atmospheric pressure is 0. Here the gauge is calibrated, or the scale which is graduated here, it reads 0. So suppose this pointer will move to the 40, means 40 bar is a gauge pressure, and to calculate absolute pressure we have to add atmospheric pressure to this value. So this is Bourdon tube pressure gauge, which is used to measure positive pressure. In case of negative pressure, means pressure below atmospheric, in the application vacuum gauge is used. So calibration of this scale is shown here. It reads 0 and the scale is graduated in anti-clockwise direction. Here this is given in terms of mm of Hg. So minus 760 mm of Hg is the negative pressure, maximum pressure possible to read by this gauge, that is vacuum gauge. So suppose if the gauge in the application is showing 200 mm of Hg, it means that here the vacuum present over here is 200 mm of Hg. So absolute pressure will be what? 760 minus 200 means 560 mm of Hg. That will be the absolute pressure in the system. Now let us see practically pressure measurement by using test rig.
So this is pressure measuring test rig. You can say pressure measuring test rig. Test rig means equipment. Pressure measuring test rig means what? Test rig is what? Test rig. Rig means frame. Equipment. Device. So on this frame, different pressure measuring devices are mounted. For example, this is pressure gauge for positive pressure. This is another pressure gauge for negative pressure. This is single well manometer. It has only one tube. This is sensitive manometer, means inclined tube manometer. And this is U-tube manometer. Two tubes. At the bottom, they have connected to each other. We call them as U-tube manometer. Now, this we are using to find pressure difference between these two locations. Here, two outlets we have in the pipe. That's why we call it as differential U-tube manometer. Understood? Now, this pressure, when we want to measure, we should have some mean of pressure. For example, in our house, at a tap, we find water. Okay. Now, this water is falling at atmospheric pressure. Okay. If we attach pipe to it, rubber pipe, and another end of pipe, if we close, in the pipe, what happens? Pressure increases, pressure develops. When we will open the end of that pipe, pressure developed in the pipe will be released. Means to have pressure there will be some push, there will be some pressure, there should be some gain. That means what we use when we want to raise the water from ground to upper floor, top floor of the building. What we use generally? Motor. Not only motor, we need pump. electrical motor rotate the pump. So that pump is shown here. This is centrifugal pump. This monoblock pump, its capacity is 1 horsepower. This is electrical motor. On the shaft of electrical motor, another side there is a impeller. That impeller is here inside this. Pump has 2 connections. One connection to the pipe, water comes, it takes the water and it discharges. So this pipe is called a suction pipe and this pipe is called a delivery pipe. This delivery pipe here for the experiment we have. And this pipe again is going to the tank. That's why it is called a return line. Now for controlling the pressure, we have some valves. This valve number 1, this valve number 2. These both valves, when we will open, what will happen? Water will not go through upper pipe because it has no resistance, no pressure. Water will follow this path and it will return to the tank. When I want to raise water to this pipe, what I have to do? I have to close this valve. Now water will be passing through this pipe. Still, this water is again under only atmospheric pressure. When we want to create more pressure, I will have to close this valve partially, not full. If I will close this valve completely, what will happen? These connections will come out. Okay, that's why I will close this valve partially. In what way I will close this valve? Pressure will build in this pipe. Now this pressure we can measure. Now for that purpose, positive pressure gauge, this connection we have given here in delivery line. This is what delivery line via this rubber tube. This rubber tube is given at the bottom of this gauge, horizontal pressure gauge. This will show us reading positive pressure. Okay, now you can see here calibration on this scale. If you see, that is reading 0, 2, 4, 6, 8, 10 and 10.6. Outer values are in bar, AGM per centimeter square. While inner scale is here, that reads 0, 30, 60, 90, 120, 150. That values are in PSI. Means LB per inch square, pound per square inch, PSI. Okay, this is what positive pressure. And negative pressure means what? Pressure below atmosphere. And this pressure is where? That pressure is in suction line. Though there is pressure below atmospheric, that's why water from the tank comes in the impeller. Impeller sucks the water. Means there pressure below atmospheric pressure, that pressure is created. Okay, so this pressure can be read how? Here in suction line connection we have taken, and this connection we have given here to this vacuum gauge. Now calibration or scale of this vacuum gauge you can see here. So here it is reading 0, 5, 10, 15, 20, 25, 30. This is in for HG. In inch, not in HG, inch HG. And outer scale is given in mm of HG. So here we are not using bar. Why? Because it is less than 1 bar. Less than 1 bar, that's why we use here 0, 100, 200, 300, 400 up to 760 mm of HG. And negative sign, why? Because it is negative pressure. Now this pointer is at 0 on right hand side. While pressure acts, it moves in counterclockwise means anti-clockwise direction. While this pointer initially is on left side. When pressure is applied, it moves in clockwise direction. So have you got difference between positive pressure gauge and negative pressure gauge as per the discussion? Now I will show you here how the pressure increases. For that purpose the arrangement is here the main switch. That main switch we start, then this is second switch. When we start, motor will be started. But when we want to start motor, at that time we have to take care that all the connections which are going to the manometer, these are closed. Okay. And the connection which is going to the tank is open. Now the flow is started. That flow is coming and returning to the tank. Now you will find here pressure. However, I am closing this valve. You will find that value of the pressure gauge is increasing. Okay, this is how much it is in between 0, here is a 1 and here is a 2, means it is 1.5 bar. But this pressure is which pressure? Gauge pressure. What would be the absolute pressure of the system? 1.5 plus 1.01325 bar, means it will come 2.6, 2 point something it will come. So in this way we indicate pressure value in engineering calculation. Understood? So this was what? Positive pressure. And negative pressure means here the pointer, generally in case of vacuum gauge, that pointer will show very less reading. Okay. And for the calculation we use only positive pressure. We don't use negative pressure. Because in the design of pipe, everywhere this pressure is important. Understood about the pressure gauges? Now next is manometer, single well manometer. Now for this what we do? We do the connection. For the connection here, you have seen in machine drawing, you have different types of coupling. Coupling means to connect the two pipe ends. We use coupler. So it has arrangement. This is the outer sleeve collar. Inside that there are some balls. These are fitted with spring. When I will leave this, these balls will go inside. When I will withdraw this sleeve, that balls will come out. Means what happens? These balls are fitting in the groove provided. This groove is provided in the pipe. If I will fit this in this way, I will leave. These balls are setting in that groove. So connection will be formed. It will not come out. Now I will show you here. Now while we are doing this, we have discussed that if we are using water column for 1 bar pressure, we will need how much column? 10.32 meter. This pipe is of around 1 feet only. Means very less pressure we can read by this single well method. Very less. How much? I will show you. Just I close this wall, say with 3 or 4 degree angle. This is 0 degree. Suppose if you are taking complete 0 degree. If I will change it by 2 or 3 degree, you will find here water is being here. Okay, it is at 150 mm of height. Means what would be the gauge pressure by manometer? Rho into G into H. Rho is of water 1000 multiplied by 9.81 into height in meter 150 is in mm. 150 into 10 to minus 3. If we do the calculation, that value will be very less than 1.01325 bar. This is what single well manometer. That's why this manometer we use for measuring very low pressure. Okay. Now next case is differential U-tube manometer. For differential U-tube manometer, the connections we can do here in this way. Now here these two pipes are provided. These are for what purpose? Suppose there is some error present in in the water line, that air can be removed. That is why these valves initially will be open, air is removed, and after that it closes simultaneously. And here is a mercury. Initially, here, if there is no pressure in the system, both the level will be showing same reading. But however, I will increase the pressure in the system. These two ends, which are apart at suppose 98 centimeters, yeah, 1 meter. Delta P between the 1 meter will be shown here in the terms of height. In the terms of height means how? You will see. Here is the leakage. If you see, you will find here difference. You will find here some difference. Are you getting some difference here? It is about of 1 centimeter. And one thing, left side limb mercury level is at down. It has gone down, and right side mercury level in the limb has gone up. Means left side location in the pipe has more pressure, and right side location of the pipe has less pressure. Means there is pressure loss between these two locations. Understood? So how much pressure loss is present here? That pressure loss we can have here by this change in the height. It will be what? 1 centimeter. 1 centimeter means in mm 10 mm, and in meter 0.1 or 0.1. 1 centimeter means 0.01 meter. 1 centimeter. So 0.01 centimeter, that much H we will take. Rho will be what? 13,596 kg per meter cube, because here mercury into 9.81 into 0.01. This will give us a reading in Pascal. Convert that in Pascal. That will be delta between these two. Understood? Now, likewise, this is what sensitive U-tube manner. For this also, we can have connection. Left side connection and right side of this pipe. Right side of this, we can connect here. Now here some mercury is present here, very less mercury. We have to fill up mercury this much in this device. What happens when we will start? The pressure developed here. The air which was present here, that air, it has to be removed. Okay. You are observing some air bubbles are coming. Application of pressure. Here is a less mercury. That's why it is not showing position of the mercury. If there is a high mercury, then what will happen? This mercury level will be changed. If I will apply this pipe here, this side will be less pressure. This less pressure means in this case that mercury level will be rising in the tube. Mercury level rises on low pressure side and it goes down on high pressure side. Okay. So that rise level of mercury we can read on the scale, and that is what L. L sin theta will be H, and rho GH will be P gauge, and P absolute will be P gauge plus atmosphere. In this way we use sensitive manometer, inclined to manometer. For this, the angle with horizontal is 30. So sin 30 will be 0.5. So L sin theta means L into 0.5 will be catch. Understood? So in this way, pressure gauges, single well manometer, differential tube manometer, and inclined tube manometer. You see. Okay.
So in this advanced age of technology, nowadays we use modern pressure sensors. So these are some sensors: absolute pressure transmitter, high temperature pressure transmitter, this is flush diagram pressure transmitters, this is range differential pressure transmitter, smart differential pressure transmitter. These are especially used in industries for the measurement of pressure, and these are expensive. Also these are used in research laboratories where the utmost accuracy is required in the measurement of the pressure. So here we can see one of the type of digital type pressure gauge used. So it is showing a reading here digitally of the pressure in the system. So at the end of this session, you can explain pressure, what is pressure, what are the different types of pressure and different pressure measuring devices, and how to measure pressure by using devices. Subscribe the channel for further video sessions. Thank you.